Hi, what I'd like to do is tell you a story of a solar storm that occurred between the 1st and 2nd of December in 2023. As you can see from this prediction chart, the actual solar storm hit us during the daytime just before 12 noon. But as we progressed into the evening and darkness would start to fall, you could see we actually started to get a pickup in all the radiation that was entering into the Earth's atmosphere, which created an aurora. And as you can see, by about 6 and 7 o'clock, especially 7 o'clock, the actual KP index had risen a lot. And as you can see as well, as we went through the evening, the actual bars go up and down, and again we had another peak a little bit later on, and this continued into the early hours of the 2nd of December. So what caused this solar storm and the resulting aurora that we enjoyed on the night of the 1st to the 2nd of December? In this short video, I'd like you to pay attention to the dark filament in the southern hemisphere, and it's just below the 3 red bright dots. If you watch it closely, it will actually lift off of the surface of the actual sun and move out into interplanetary space and start its journey towards the Earth. That is the start of a 3-part event that actually happened to cause this solar storm. And if you continue to watch, you will actually see the area to the right of the actual filament brighten, and then you'll also see just above the equator in the other active region, the other bright spot, you'll also see an eruption from there. As the video continues, on the sort of like in the northern hemisphere towards the left, in between the sort of like the 10 and 11 o'clock, you will also see another eruption, and this is the start of the second part of the actual solar storm. In this second video, as I said, we've had the first part of the, as I will call it, the second event that made up this solar storm. If you watch again towards the between the 10 and the 11 o'clock region, you will actually see a huge flare, huge CME liftoff. This huge filament. It's almost like a wishbone. It's in a V shape. It lifts off, and then it starts to move its way towards Earth. And this was the actual main part of what we call the second event that actually made up this solar storm. But as we continue to watch on, if you look at the bottom hemisphere, the third dot on from the right, you can see that it's much brighter than the others. And if you look at it, it's spitting and it's hissing and it's really angry and it's really kicking off. And what happens is if you watch it towards the end, you will suddenly see, you'll actually see a little sign come up saying eruption, and it will brighten just slightly. And this is the main part of this eruption. Now this one's far more violent than the other two, and it moves away from the sun at a far greater rate. Here we have the NOAA space weather prediction of what these actual storms are going to do and how they're going to travel to us on Earth. The diagram is divided into 2 parts. In the upper part, you've got the round circle. In the center, you have the sun, and off to the side, you'll see you've actually got the Earth marked. Now we're looking down here from the north pole of the sun down through the south. To the right of that, you have a fan shape. Now this is what we've sort of cut down through the middle of the sun, and we're looking from west to east of the sun. So we're looking at a side-on view, because what you have to remember is the sun and space is 3-dimensional. It's not just 2-dimensional. The bottom diagrams, again, you've got the sun in the middle, To the right you've got the Earth, and the other dots are satellites that help make the predictions on these things. And then you've also got again another fan shaped, which again is looking from the side, and it'll show you the direction of these things are actually traveling. Now what you have to remember is that the sun is a sphere. It's not a flat disk, it's a sphere. So where the actual eruptions take part will dictate where they travel out through into space. But as you'll see, they don't just sort of like in one spot, they actually spread out. And depending upon how violent they are, it will depend on how much space, how much they will fan out, and how much space they will actually cover. So what I will do is I will actually start to run this for you. And what you will see, first of all, is you'll see from the sun a small green sort of like banana shaped thing start to move away from the sun. Now this was the first eruption of the CME that we saw on the 27th. As you can see, it's all in green, it's not very powerful, it's a bit sluggish moving away, but it's going to go to the west of us, but also you can see it will actually go to the south as well, so it's going to go to the southwest of us. But as again, remember, we're thinking in 3 dimensions, and it's not just a wave that's coming from you like from the sea in one line. You've got to imagine this as a shield, like a shield, a concave shield that's moving towards us, and the more that it's actually the eruption takes part in the center of the sun, the more the direction it is to us. But this one's moving to the southwest. It will shortly be followed by a slightly more the events that happened, the 2-part event that happened later on, and you will see that this is far more colourful. It's far more powerful. There's a lot more involved in it. But again, it's just moving away quite slowly, quite sluggishly towards Earth. And what these two are actually doing is that as they move forward, as you saw when we were looking at the videos, you can see all these other smaller events that are happening, little eruptions and things like that. Now, of course, they're also throwing out space weather towards us, but they're moving away slowly. They're pretty irrelevant. But these storms, the bigger ones, as they move forward, will catch up with those, and they will sort of like combine. They don't get absorbed into one another, but what happens is, because these storm lines, as you can see, are actually full of lots of magnetic lines and magnetic fields, and they have and inside that is captured all the radiation which will cause the storm. They're all rushing up and down these lines, and it forms sort of like the only way we can describe it is a cosmic slinky, and all these energetic particles are whizzing up and down the lines, and there is a structure inside, a magnetic structure inside, which we cannot guess at until it actually hits the actual Earth. I won't go into it now, but it'll have a north, south, east, west component that going on, and whatever the combination is of those 4 things, then it will depend upon what sort of reaction the Earth will have to being hit by this storm. Anyway, we've got the second storm moving in. Now, if you watch, there is the 3rd event, the more violent event, and look how fast it's moving away from the sun. And of course, as you can see, it moves along behind them, and it catches up with them. They're all buffing up. It's like bumper cars. They won't merge together. So now we've got sort of like 2 really big storms pushed together, and they're compressing each other, which gives them more energy and more power. And of course, with the extra speed, it's going to hit the Earth at a faster speed. And this is what happens, and you can see it hits the Earth, and then we can see, we know what the results were. We had there was some radio disruption, GPS disruption, nothing serious, and then of course we got the lovely aurora. There was no worry about aviation because the radiation storm wasn't that great. So as you can see, so what's happened is we've had the 3 events come out. The first 2 have swept away all the junk but in front of the main event, so it's basically had a free run at the Earth with nothing to sort of like get in its way and slow it down. Then they all combine, and then we get this free phase storm that hits us. And that's reflected in the fact that you can see, if we go back to the original slide with the bar chart, you can see it's up and down, up and down, and then as you move away, and if you look at the lower diagram on here, you will actually see that as the actual wind, the solar wind speed, you can see the direction it's traveling at, but you can actually see as they leave Earth, you can see the 3 phases that are already in there. So that's basically what really happened with this solar storm that we had on the 1st and the 2nd of December. Just to finish off this presentation, I thought we'd like to have a little quick chat about the cycle 25, and that's the sunspot cycle. As we know, they usually tend to last about 11 years, but that's an average. Sometimes they can last 14 years, or they can last as short as sort of like 8 years. But on average, we say that they last 11 years. Now in this chart you can see there's a jagged line, and also you can see on the left hand side that is the peak of cycle 23. Then you come to the middle and we've got the peak and cycle 24, and then to the right you can see the peak of what could be the peak of 25, which is the cycle that we're in at the moment. Now you can see there's a red line where it says cycle 25. Now that was the predicted number of sunspots that they expected to see, and they expected it to sort of like peak in 2025. Sorry, but as you can see, the cycle started quite dramatically. We got quite a sharp rise in sunspots, and as you can see, we did actually go slightly above what 24 achieved, and 24 was considered a slow sunspot cycle. There weren't that many sunspots, and 25 has been predicted to be the same. And as you can see, we've just peaked above it, but we've already started to drop down. Now if you look at this, we were sort of like about I think it was, I can't really read on 150, above 150 sunspots at its peak. Now then it started to drop down. Now what we have, that would the peak was in, I think it's end of July, August. Then it's dropped down through August. And then it's continued, then it rose again for a little bit in September, dropped down again in August, and then there's a little tail on the end which is going back up again, and that's November's. And as you can see, November, although I thought it was going to be quite a bit more dramatic in a rise, it was only very few sunspots have actually occurred. Now this can either mean, one, we're coming into the solar minimum, where the sunspots will slowly decrease and we'll enter into the minimum, and then eventually the polarity on the sun will change, and then we'll go into cycle 26. Now this can either again be a short period over the next 2 or 3 years, or it can be extended and we can go as far as 11, maybe even 12 years. But although that means that we've come from the peak when the sun's quite active, we also find that in this minimum period, we also find that the actual sun is just as active, if not more so. And of course, with an active sun, that protects us because it's throwing out far more solar storms and in the solar wind, you've got the magnetism from the actual sun stretching out beyond Earth out into the solar system, which forms our heliosphere, and that actually protects us from dangerous cosmic rays coming in from outside the solar system. But as we come towards that and the sun actually does start to slow down, then of course the reverse happens. The heliosphere shrinks and we get more cosmic rays come in rather than release energetic waves coming from the sun. So we're either going to have a short cycle or we're going to have a long cycle. But there is also the possibility, maybe a possibility, that we may start to peak again. If you look at 24, it had a peak, then it dropped down, and then it came up to another peak. So we could have it coming in to just had a quiet period. We may bounce along, and then we may have another peak. So I just thought I'd like to point that out. Just as an example, last week we had 60 sunspots at one time on the sun, and I think the sort of record is something like 250 in one period of time, in one rotation. So that's what's happening. It could be that we've started to come down, and we're entering into the minimum phase, which could be either short or long. We could either double peak, but it's a watch this space. It's just fun. I just think it's fun to watch how many spots, how it goes up. Basically, you can see all the time. We can't predict anything here. 1 minute is low, 1 minute is high. And we've just got to wait and see what actually happens with that. I just thought you'd like to know what the actual sunspot situation is. So that's the end of this presentation. I hope you enjoyed it. It was I hope it was informative for you. But it's just basically to tell you what happens when we have a solar storm. So until next time, take care. Bye.